Hey everybody, welcome into another fun and exciting geometry class. Today we are going to be on page number 27, lesson 1.16, congruence. We're going to talk about what it means to be congruent to something else. Now, maybe that's a new word for you. You've never heard that word before. So let's start off by kind of explaining what the concept of that word means, and then we'll talk about some different things of how we're going to apply that in geometry. So the word congruent, I'll go ahead and write it here for you so you can see it. Congruence, I'll write congruence. Sometimes we'll just write congruent instead of, it's just different form of the word. But congruence, what is congruence? All right, so let's talk about that word. Here's what it means. If you have two shapes, they have to fit two different criteria. They, number one, must be the same shape. In other words, they have to be exactly the same shape. Two triangles. Well, two triangles one could be like this, and then one could be like this. Well, those are two different shapes. Now, let me draw a little bit better. That was terrible. I know, I'm a bad triangle drawer, okay? So there's one, and here's another one. I'll draw it really bad, really different, okay? Those are not the same shape. So these could not be congruent, okay? When I'm talking about the same shape, I'm talking about exactly the same shape, not both rectangles, okay? Both the same shape rectangle, because you have different shapes of rectangles. Okay, some are long and skinny, some are, bigger, wider, different things like that. So they have to be the exact same shape, not just both triangles, not just both rectangles, not just both pentagons, whatever it is. Okay. The second thing is they have to have the same size. They must be exactly the same size. Okay, and that's really the easiest kind of definition. Now, the technical definition is this. They must be able to coincide. Coincide. Now, what does it mean to coincide? We've already talked about this, I believe. The concept of coinciding is being on top of each other, okay? In other words, they need to take up the exact same space. So if I were to put triangle A on top of triangle B, those two things need to match exactly. Point A needs to match with point C or point D, whatever it is. Point B needs to match with point E, and point C needs to match with point F, whatever it is, whatever the points are labeled. But every point, and then line AB needs to match with line EF, for example. Everything needs to match up. All the angles the same, all the sides the same, everything the same, congruent. Now, you might be thinking, well, that's really easy. I'll just measure everything. I'll just take my protractor, and I'll take my ruler, and I'll just start measuring everything. Wrong. Okay, remember, we can't use our protractor. We can't use our ruler. Those do not exist in geometry. Very, very rarely does geometry allow us to use those instruments. So, we have our compass and our straight edge. That's what we have in geometry. So we have to make this happen with a compass and a straight edge. We can't measure anything. So congruence, every piece, every part needs to coincide. That means that they need to be the same shape and the same size. So I've got a little kind of demonstration I want to show you, and then I'll come back in just a second and kind of explain some more things. Okay, so what you just saw was the idea of superimposing. Maybe you've heard that word in photography. When you superimpose something, here's what it means. You put it over top of the other one and then you put it down. So if you want to make certain like trick photography or different things like layer your photography, so maybe it looks like the sun is coming up or something, you superimpose images over top of the other image. And once you get enough images, it looks like animation or it looks like movement or whatever you're trying to accomplish with the superimposing. Well, when you superimpose shapes, you are putting the shape over top of the other one. Now, wouldn't it be nice if, like that video, we could just take the shape and move it and see if it fits or not? Well, this is the problem. The book says superposition is usually a mental process. In fact, for what we're doing, it's always a mental process. We never take and cut out the paper and put the one on top of the other. We always use our mind to do it. Now, it's not like some magical power that you're going to make the paper move over. What we're going to do is we're going to prove it by using things that measure, things that use identity properties and other things that can say, oh yes, this is equal to this, and this is equal to this, and so they must be congruent shapes. And we're going to get into that. It's not going to take long for us to start getting to that, what's called proofs, where we're proving things. But we're still laying some of the groundwork on that. So congruence, the sides, everything needs to coincide. They need to be the same shape, the same size. Mentally, you're going to have to think, okay, if I take that shape and I turn it, and then I move it over here and put it down, is it going to be on top of the other shape, yes or no? And you can't do that. You can't mentally do that. But what you do is you say, okay, mentally, does AB match EF? Yes? Okay. In your mind, that piece goes down. Does angle A match angle E? Yes. That piece goes down. Okay? And so that's how we build congruence, by piece, by saying, okay, AB matches, boom, that's in place. It's almost like a puzzle. Okay, you get the puzzle to click in, you finally got it, and you move on to the next piece, and you get that one to click in. And these are like puzzles. And so we prove congruence by clicking in pieces of the puzzle. Once we get a certain number of pieces clicked in, then we, and we'll talk about that in the next few lessons, but when we get those pieces clicked in, then we say, okay, we got congruence because we have this piece, and this piece. Most of the time, congruence takes 3 pieces. The triangle has 6 pieces. Let's talk about a triangle right now. It has 6 pieces, okay? It has 3 sides, and it has 3 angles. So there's 3 plus 3, 6. The triangle has 6 pieces. And if we can click 3 of those pieces together in our minds or on our paper, then we can say, hey, we have congruence. These coincide. They're the same shape and they're the same size. And so that's kind of the direction that we're going. You may or may not have understood everything that I just kind of talked about right there, but that's the idea. If you will go to page number 28, I'm going to do both of these lessons in the same, because really they are the same lesson in a way, and I've kind of already gone into it. But with congruent triangles, and you'll see right there the idea, and this is how they write it. Let me show you the sign, the symbol for congruence. All right, so I'll just write it right here. So you have an equal sign, and then you have the little thing over top of it. It's kind of like that. It's like the little thing that they put over the Spanish ñ, okay, the little N with the little thing over top of it. That's exactly what it looks like. So you put a little equal sign and then a little ñ thing over top of it, and you have the sign for congruence. This is the symbol for congruence. Now, they're not equal. Okay, and we'll talk about why they're not equal and what that means, but they are congruent. Let me see if there's anything else here. It says there in the paragraph that there are 6 parts of any triangle. In order to get those, you need at least 3 of the parts to be, and And once you get 3 of the parts, then the other ones kind of fall on top of each other, and then it proves congruence. I'm just trying to see here if you need anything else. I think that's it. I think that's it right there. Now, one thing that your book is doing, if you're looking in your book, when they label a triangle, so let me throw a triangle up here. They'll label this A, B, C, for example. In the other triangle that they're trying to prove congruence with, let's put this. And I know it's not congruent, okay? I didn't spend the time to make it congruent, but we're going to pretend like it is. Well, maybe they'll name this one C, C with a little mark, a little hash mark, tilde. It has a name. I'm not going to tell you the name of it right now, but it does have a name. We'll get to that in a little bit. And then this one would be the A with the little mark on it, and this one would be the B with the little mark on it. And then what you would do is you would say, if you prove it, once you prove it. Now, these ones aren't. I know they're not, but we're going to pretend like they are. So we would say that ABC, and we call that triangle ABC, is congruent to triangle A with the little tilde, B, C. Okay? And that's how we would do it, is use those little markings. And you could name it something else. You could name it EFG, whatever you want, XYZ, any designation that you want to name it. Okay? All right, there you go. There is your lesson on congruence. And we also talked about the idea of coinciding. All right, we'll see you later. Have a good one. Bye.